All right. So side channel attacks. Let's just jump right into it. Channels, right? Information channels. So just to keep it brief, we're gonna treat a channel like as just like any way that we can get information out of the system. The easy way, say, like if you're working with a web server, might be to like shoot a GET request or some other request out of it. You'll get some information back, like the status code, the content of the request, and so on. Like if you're working with, say, like a physical device, like, and you send like, say, two like a high and a high into an AND gate, you're expecting to see like, say, like either a high output or a low output if it's broken for some reason. So on and so forth, right? Hopefully this is clear enough. I'm going to quickly just blast through this. So side channels, right? So I've covered what some examples of main channels are. Side channels are literally anything that maybe the developer wasn't directly trying to interface outward when they create like the communication protocol. So for example, like if we're connecting to a server and we're trying to get as much information out of the system as we physically can. The easy way would be like, if the developer set up some endpoint and go and talk to it, it'll run some computations behind the scenes and then spit out whatever response the server is intended to give us. Say if this was like a website, had like a login page, right? You type in your username, you type in your password, you hit login. What happens behind the scenes? Well, your device sent a request to the server saw the request that contained your payload, it maybe ran some calculations against the payload, and sent you back a response. Now, if you're just looking at that pure interface that the developer, or like, let's say the developer only intended you to see these main channels. Well, like you'll either get like some binary like 1 or 0. Did I log in correctly or did I not? Maybe we'll also have some other like metadata like headers, but for the purposes of this talk, we're not really going to consider it. Things get a little bit more interesting when you start looking at some of the side channels. If you say have I guess like if you're generally communicating with the server, you'll be able to see metadata about, oh, how long did this request actually take? Perhaps you can infer based on the number of calculations I had to do, how much time it might need to take in order to do that process. Maybe if you're closer to the correct answer, it'll take more time to do the computations because you're closer to getting it right. Similarly, another common technique that's used, or another common method that's used for side channel analysis is power. So especially on like physical hardware, like there's famous attacks like row hammer that just like slam electrical current at specific parts of certain chips and are able to leak out a lot of information or change bits in adjacent cells by doing that. Here, like if on our password checker example, say like you can like say that instead of a full-on like web server, you instead had some embedded device. The power output or the power input, I should say, consumption of an embedded device is a lot smaller and perhaps a lot narrower of a range compared to what you might consider from like a full-on PC. And from that, like if you can notice like, hey, like I'm noticing that my thing is getting really hot or it's like using a lot of power under like XYZ conditions, like say like a certain time of day, you can maybe infer, oh, this thing's probably getting a lot of traffic during that time. For a password checker example, if you're noticing that like it uses more power when you're getting closer, you might notice that it uses more power as it gets closer to the correct answer. In the same kind of vein that it's doing more computation. Okay, so hopefully I've sufficiently motivated that. Do you guys like all agree that like this is something interesting that maybe we should investigate further? Yeah, okay. Right, let's write a password checker, guys. You guys excited? Yeah, okay. Actually, I lied. No, you're doing it. Volunteers? You get 5 minutes.
No AI. Not allowed.
Yeah, actually, I include that on the rules. All of you guys get a shot at this, actually. Go ahead and ping me in the CTF channel as soon as you like finish the solution. Feel free to open the VS Code or whatever. Just turn off Copilot. You're not allowed to import any libraries, and you can't slop with AI, please. I'll look at some of the first ones that come up.
You just were talking about the power. There's the cold boot. There was for a while before they started spacing out the space before on laptops between RAM sticks and USB slots.
Mm-hmm.
At cold boot, if you're able to apply just the right amount of voltage to the RAM slots, you can jump data from the RAM to the USB slot and then exfil data that way.
Wait, how did that work? Is that like a hardware issue?
Yeah, no idea. It's over my head. But I talked to a reverse engineer at DEF CON last year who was telling me about it, and I was like, that's fucking insane.
Yeah, no, side channels, like, in my opinion, lead to some of the most interesting attacks. And it's also like really fun too, because even if someone's taking like a security conscious mindset into like trying to build out some system or design some system, one commonly overlooked attack vector are side channels. Like if you can somehow like have some way to deterministically impact the input and observe some deterministic output or deterministic change or semi-deterministic or statistically deterministic change in a side channel, you can leak information pretty consistently through that. Like another application that I'm not going to really talk about today is like if you have some sort of SQL injection. Like I'm not sure if they're still running this lab, but in intro infosec, like one of the classes you'll have to take here as a cybersecurity thread person, they had like this one lab where you were practicing running SQL injections, and like the server would send you like a response of, hey, like you either logged in or you didn't log in, but you could actually leverage that, say like that channel of like, oh, like did I log in or did I not log in, to craft like a specific SQL query that would the goal of the SQL injection is just to log in. It's not necessarily, yeah.
Yeah, it's still like taught in the last one of the labs ones where it's like I think it's more of the hashes. I think it's just the hash is small enough we can just keep guessing. Like when it says like you didn't log in, you just keep guessing the hash until you get correct.
Oh, interesting.
Because it's how they do is like they take in the password.
They just like look at the first like characters of the hash.
It's like they take in the password, put it in the MD5 hash, and then that's your password, and so you just keep guessing.
Mm-hmm. All right. Did I get any pings yet? I have not gotten any pings.
I looked it up. It's called a cold boot.
Cold boot?
Cold boot or RAM dump.
Interesting.
We'll extract leftover data from the RAM on boot if you have a memory dumper loading from the USB drive.
And there was anything like they freeze the RAM with like keyboard cleaner or whatever and try it.
I think so. I'm not 100% positive. That is out of my wheelhouse. I primarily stick to threat intelligence. I'm good.
Oh, I guess like to finish up my anecdote from earlier, you could actually use that binary 1 or 0 of like did I log in or did I not log in from my SQL injection to leak out the entire password of the user. You could like change it so that your SQL injection becomes, rather than like apostrophe space 1 equals 1, or sorry, apostrophe space or 1 equals 1, then comment. You can instead make it be like apostrophe space 1 equals 1 and the first character of the password is the letter A. And you can spin through the entire alphabet by doing that and eventually leak out the entire content of the password. Of course, it's a lot easier just to do the lab exercises, but who am I to say? Yeah.
Question. So wait, if you're just let's say you're just using Python,
Mhm.
just let the user input like a text string, and then you typecast it to a string.
Yep.
How can you, I guess, assuming Python hasn't been designed for it, how can you hack that, or do you just have to like hack it?
I'll show you. I'm assuming that like, especially for people who haven't really heard of side channels before, haven't really seen this specific exercise before, you'll probably write your implementation of this checker in like a probably like fairly like consistent manner. And I'm hoping to take advantage of that for this demo. Yeah, thanks, Michelle.
That's a mistake.
You can keep it up there. I'm not going to count it, but like,
It's yeah. You never log in.
Secure.
Yeah.
it is extremely secure. No one's logging it. Actually, it's not very secure because you fucking like violated the like what CIA, like the availability of the system.
Oh well, yes.
Oh, in CTF. Let's put some activity on there.
Is Rishi in y'all's Discord?
All right, we have a submission from Nash. Is hash a built-in? What hashing does he use?
Test and prod, find out.
Does it have to run or can you just run pseudocode?
Hmm?
The
You
code has
can
to-
write pseudocode.
Awesome. That makes me.
I'm pretty sure it's a code 10.
I type slow.
I mean, I'll give you like a the goal here is that you guys are going to write me some really, really bad implementations.
I'll read you why.
Well, bad implementation. Okay.
Okay.
This one should have this report.
You like to break one now?
Okay, I'm gonna give you guys a little bit more time to work on this. I'm gonna give you guys like another minute or two.
Yeah, I don't really have password.
These are some really interesting implementations, guys. I have not seen. Okay, it's a very interesting implementation of password checker, man.
These are bad implementations. Okay.
Okay, I did. I'm getting what I asked for.
I can't wait for you to start showing the stuff and how you're gonna break them.
Yeah.
Add as many lines as you can.
I got you.
Think as difficult as possible to understand. Change the variable names.
Just put your.
Is anyone still working on an implementation? Okay, a handful of you guys.
Your life extension tax.
Should they try to make it as difficult as possible?
Oh.
Have fun with that. Get down and dirty, because if he's gonna give you a challenge, you should, he didn't really specify the rules, you should just use the fact that no rules.
Yeah, I can put in a line that's like. delete this orange line.
I'm not gonna run the arbitrary. I'm gonna read the code before I run it, man.
Hey, real man test introduction. Come on now. Something's good.
Yes, I'm gonna test on my daily driver laptop that I'm gonna be using to submit homework later tonight. That'll be a good idea.
AWS
Your laptop's
testing
come
prod.
on.
Yes, I enjoy all the GCP keys that are on my laptop. I enjoy absolutely every single one of them.
If you inputted the password wrong, I'm wiping all your SSH keys. I'm wiping your entire key ring. Goodbye.
You can do that?
Hmm?
Can you wipe keyring from just some arbitrary program without any permissions?
I've seen malware that does it. It just completely annihilates. It basically wipes your key ring, it then wipes everything, but that's only if it gains full access to the machine.
return.
Okay, that feels like an if.
If If you have decent common sense, that will not be possible.
It's a pretty big ask, I'm not gonna.
It's a really, dude, the things I see. We had a client, they
I've Mike, by the
quote
way.
unquote accidentally excluded all of System 32 from their scans from our EDR region. Yes, could you like take a guess what happened? Let me rephrase. Take a guess what flavor of ransomware they were hit with.
Okay. I'm gonna go ahead and change my screen share to be my VS Code, hopefully.
Which was a cute.
Hey, can you guys see this?
Yep.
Cool. Please work Zoom. Okay. Let's I guess just start with, I think this one's from Nash, this top one. Right, so you have create account, username, password, username and users, return username already exists. Otherwise, like you create the new user in the dictionary. For login, same API parameters. You take in ideally 2 strings. If the username is non-users, then you reject it. Otherwise, if you can index into the dict and you get that username, you will compare it against the password. And if it's the same, then you log in. If it's different, you return invalid password. Just to verify that this program does in fact work, let me go ahead and just run it. Python t.py. Oh, I probably need main. Oh. Thank you. That was fun. Okay. Okay. So we've got like this current script right now, right? Let's just go ahead and launch this for a demo. Python t.py. You get like username and password, right? So I'm just gonna have my username be Nash, password be very good pass, and we get login successful. If we type in literally anything else, fails. Cool. Just for the purpose of keeping this concise, I'm just gonna have the username already set for us. We're just gonna type in the password. Okay, well, I guess just starting out, anyone that did not already know or hasn't already seen this example walking through the door, have any ideas for how we might be able to approach leaking out Nash's password? Yeah, Vishal?
First of all, are we doing this from the perspective, like in the code itself, or like from like the perspective of like trying to log in?
Could you clarify what you mean by that?
We're just the console, right?
Yeah, like you are the,
Let's use the console after Python t.py has been run.
yeah, like say like you have like, you know, we have like some def run, I don't know, attempt, right? That just takes in a password. And it does all this. Let's assume that like the account's already been created, okay? And attempt will just attempt to log you in as that person. Okay. And you can run this as, you can do whatever you want inside of main, other than like, like maybe just anything with respect to attempt. And like, let's not try to dump bytecode and stuff right now. So I guess just by running attempt and keeping track of, the results of different things that you're doing using it, is there any way that we can deterministically or statistically get a good idea of what the string that Nash's password is might be?
Does Python's equals like for strings, does it check every character in order?
Yeah, it's a good question. This is something we can actually Google. So let me just go ahead and do that. Like short answer is yes, but I want to. Okay, actually, for the purpose of time, yeah, you can assume that the implementation of Python's like string compare is equivalent to like a C string compare. So you iterate, you start from like the same character, like you first check that the strings are equal length, and if that's true, you move on to the next step, which is that you go through each character one by one in the string until you either get to the end of line, or sorry, the end of string character, which is a null terminator, or you get to or like the character is different. So if you like go A, B, like if you have two strings, one of them is A, B, C, D, one of them is A, B, C, E, and you go A, still good, B, still good, C, still good, but then you get to the D and E, it notices that it's different, and then it returns right there. I guess like let's just pause right there, right? Just based on that alone, can you guys start to see what the issue is with this naive implementation of a password checker? Anyone? Hopefully you guys are paying attention, not just staring at your laptops for the last 2 minutes while I was yapping. Yeah.
You could you could guess like A and then which run stuff, B and then which run stuff, C and then which stuff, and complete like I would run all of them like 4 or 5 times and see which one has the largest mean.
Mm-hmm.
And then that would give you that would very likely give you the correct first letter.
Yeah, that's exactly it. I'm going to see if I can steal a whiteboard marker really quickly. No, okay. Okay, so essentially what our password checker is doing, right? Like when we're doing this like def, like check pass. It's not what I called it, but you guys get the idea. We're iterating through like for character in our string. Right? For C, I think this is Python syntax. It's like if, and it's like call like real P our actual password. So if okay, so I'm gonna go ahead and actually pause right here. Just based on this code alone, what can we leak from this password checker without knowing any of the future implementation of how I'm going to do the actual like character checking? Darshan.
You could, in theory, you could brute force it by going character by character, and then once you have one, you can go into the second.
Okay, I guess like just looking at this implementation that I have on the whiteboard, just with this stuff that I have so far, without having implemented any of the actual checking logic, what can I leak from this? Yeah.
Link the length of the password, because if you can look at the runtime that it takes to run the check pass, and if check pass returns immediately, you know that you got the wrong length. Otherwise, if it takes a little bit longer, then you'll by the length as the time increases in length, you'll know that you've got more and more of the password correct.
Yeah, that's exactly it. Like even like I'll just stop on the first part. You're completely right for all the remaining parts too for how I'm going to implement this. But just even for that first part, right? We can tell like if we have a like let's just say it takes a milliseconds or a microseconds in order to run this like part of the code, right? Let's assume that the return is of negligible time, and we're gonna have to do it regardless of what branch we exit from. So we can effectively ignore it. So if we decide, like, we run this program like a few dozen times with for every different type of input length, and we notice that, hey, when I run it with input length 7, for some reason, my program takes a few milliseconds less to return. Unless like the program length is 7, the program takes a few milliseconds less to return compared to if it is any other number. It will return sooner if it's any number other than 7. You could reasonably infer that the password length is 7 solely due to the fact that it's attempting to even try doing this additional logic that is after A, which adds to the runtime of the program, which in turn will result in a higher runtime of like because it's a higher runtime of the program, you just leave that. Okay, so I guess like moving on. If you want to just like walk through exactly what you just said again, I'm like just walk me through the implementation.
Sure. So like you could just check like if pi equals real pi, then, or rather not equal to, because you want to check the whole string, right?
Yep.
And so if that's not true, then you return false. Otherwise, you return true outside the for loop.
Mm-hmm.
And would that be outside of the for loop?
You're right. Yeah.
And yeah, that again will because it's taking, it will take more it'll take more iterations to find out that you have a wrong character. If you have most of the password correct, it would take it would take more time, and you'll know that it's you've got part of that correct.
Yeah, that's exactly it. So the key idea is just that because we can kind of run as many password guesses as we would like, we can just keep rotating the password, or for each character that we're using, maybe do a couple of different tests for each character with whatever current password string we have, in order to figure out what character is most likely to be the correct next character. I think a good thing to know also at this time is that, especially when you're testing against a remote challenge, especially say if this is like a pwn challenge for a CTF, you also have to account for network jitter. And the way you do that is just by doing, even if you're running locally, right? Like your computer hardware will schedule it differently. It'll take like different amounts of actual time for it to finish running compared to like if you just do it between two separate, like any given instances of you trying to run the program, even with the same inputs. So if you can just take a large sample, say like a few hundred, or if it's like very, very jittery, a few thousand instances, and do as we were talking about earlier, and take like the mean or median of those runs, you'll then be able to get a much better gauge for what the actual computation time is being spent on that process is, without the added noise of whatever the network is doing. Are you guys with me so far? Have I lost anyone? Am I going too slow? Yeah, okay, let's speed up again. But yeah, so I guess given this, okay, this is what's going on under the hood. Like when you do the not equals equals, like what Nash did here in one line, is effectively all of these lines of code. I think there's a good chance that Python is written in C, so I guess C Python's written in C. So I do believe that like they might just be using the C implementation under the hood for when you do this sort of password checking algorithm, but the same principle applies. This isn't any sort of special secure like string compare algorithm that is able to like return the same amount of time no matter how long or how like what input you give it. It's the same algorithm at the end of the day, even if it's written in a different language. Okay, so I guess given this, how do we go about exploiting it? So Neil? Oh, okay. I already explained it once, I guess. No, okay. I'm so sad, Kevin. But yeah. Yeah, you just like run it with each character. I guess like let's just say we. Mm-hmm. Yeah. So just I guess to reiterate what you said. Sorry, what?
Never mind.
Okay, just to like reiterate what you said for the people who are online. we're just going to go through every letter of the alphabet that we think could be in the character set of the password, and we're going to measure those times, and from that like try to determine like what is the what time is like taking the most.
Yes.
Okay, sorry, go ahead and continue. I cut you off.
No, that's it.
That was like, okay. So that gives me the first letter of the password. I'll give you that. What do I do from there?
Five letter.
Okay, so I do that for each ith letter. How do I like say like after say I think that the first letter of real P is the word like is letter P. What do I send to the server next time if I want to try starting to click the second character of the password? Yep, you keep this first letter and then you append the next letter you're trying to test out. So you send out PA, PB, PC, and so on.
Right. So before you do that process, you probably should send a bunch of different length strings to check whether the lengths are correct.
Because this will probably kill this entire strategy, right?
Yeah.
Okay. So I guess how do you account for that?
Once you do that, you should send like PA, XXX, and X equals the right.
Yeah. I'm just gonna say like J or Z. Right. And we're gonna keep spinning this until for every letter, like every time we are ready to test a new letter, we're confident up to like letter I. We can then like lock those in and keep spinning on the next one. So like say we keep doing that, we get S. Anyone have any guesses what the password is? W.
No.
O.
No, don't know, it can't be.
It literally can't because I only had 7 letters here. T. Oh, squad.
Passkey.
Okay. But yeah, you get the idea. I'm realizing now that like I was hoping that you guys or someone would use a for loop. Maybe I should have specified that. You did? Okay.
You started working, you forgot about Discord.
Yeah, yours would have worked. Oh well. Well.
Wait, what's wrong with that?
Oh, I said would have used a for loop to iterate over the letters, right? That's what you did?
Yeah.
Yeah. Like it makes it easier to see, I guess, when you have the for loop actually unrolled. At the end of the day, as I mentioned, even when you use equals equals, it is doing this under the hood. It might just be written, like it might be in a compiled programming language just for speed and efficiency, but it is still doing the same exact algorithm, and as a result, is like vulnerable to the exact same process. Though your timing might have to be a lot tighter if you're running against like a C server or something. But yeah, yay, we leaked password. Yay. Yes.
Like hash the password such that like it's like guaranteed to be a specific length.
Yeah, that's an excellent question. What happens when we hash a password? I was waiting for someone to ask me about. I may like have to reshare my screen again. I have like 2 more slides, guys. Just I'm sorry. Okay, yeah. So hashing, like it's like okay. So the question becomes like how. Well, we all clearly see that this is an issue, right? We can leak passwords, right? That's not good. Why isn't this happening every day on the wild? Every time we try to log into like Instagram or Facebook or whatever you guys are, I don't know what you guys are logging into these days. Right, like what we actually do behind the scenes for most like modern password, like for algorithms like this, or I guess not for algorithms, for applications like this, is that rather than actually saving the user's password in our own database, which again is also an issue because you don't want to be holding on to the clear text password of a user and say like the next time you get a data breach, oh no, there goes all of my users' passwords. Wait, don't tell me that some people are reusing passwords on different platforms. That would be tragic. I'm sure you guys don't do that. Anyway, yeah, we can use like a algorithm, like a hashing algorithm, in order to generate like hashing. Like there's a couple of different properties we actually care about with respect to hashing algorithms. In general, like hash is a way that we can turn some like arbitrary data into a more consistent format that is deterministic, one way, collision resistant, meaning that like you can't just find very easily 2 things that result in the same hashed output. Computationally expensive, meaning that you can't just like like run them in like a for loop and just spit out every possible hash there is and just get like a very massive trove of data. And then also constant length. meaning that no matter what input you throw in, you will get the same length output. So if you see like something like SHA-256, it spits out 256 bytes, or I guess bits of data. But yeah, you guys get the idea, yeah? So in addition, for a password checker, if we're going to use a hashing algorithm for this, we also want one that's constant time for this exact reason. If it ever becomes the case that depending on what the data of the password is, you're able to get a different timing output from it, you can start side channeling it as we did in class. Okay, that's all I had. Any questions? Yeah.
So in that password checking algorithm, what if you made it so that like it waits, let's say 5 seconds, and up to 5 seconds then return whatever, and every time you run this function, it always takes 5 seconds that way?
Yeah, that's a good question. So what would happen if you, instead of making it so that you just return immediately, you made it so that whenever you're about to return, you wait 5 seconds before returning, right? Is that what you said?
Yeah, so like no matter what the input is, it always takes like 5 seconds to return.
Yeah, okay. That's a good question. Okay, so that's different than what I originally interpreted as. What I originally interpreted as that you're adding like a sleep 5 every time you were running the program, which wouldn't have really done anything. So if I'm getting it right, you want to keep track of the amount of time that you spent already in your program, and then afterwards, before you return, just sleep as much time as you need, so that becomes 5 seconds, right?
Yeah.
Okay, so the issue with that becomes if, let's just say you have a password that is really, really, really long, or some input that's really, really, really long, and it ends up going beyond the 5 seconds of computation you need. What do you do then? You can't really undo time.
I think if your password takes that long to parse, then you use automatic, or at least automatic communication. I was like, if your password's longer than 32, it won't even accept it. Go log in.
Yeah. Yeah. I mean, again, there's tons of say, different variations of this that you could try to say oh, well, what if we did this? Oh, but this can happen instead. And again, the reason I'm kind of settled on using a hashing algorithm in order to keep track of your passwords isn't that it's necessarily the fixing solution for one specific problem, but rather it's a solution that works for many different types of problems that you might face when you're dealing with, say, a password checker. So, for example, if I had access to the physical hardware, there are techniques that allow you to make it so that even if you can see the computation in motion, say if I'm another process on the computer and I'm able to side channel some my scheduling information based on how much computation resources that other process is using. Say if I'm able to notice, oh, I'm noticing that it's keeping continuously doing this rolling loop, and I can just keep sending tasks for it to do and monitor its output in that manner. Okay, I need to go back to your original question. Sorry.
Do you want me to repeat it?
Yes, can you repeat your original question?
Yeah, so essentially this function, let's make it so that it always returns at 5 seconds or 10 seconds, and no matter how long it takes to actually check the password, we wait how much we need to until we get to some time.
Oh, okay. So you just wait okay, and then you followed up with why not just reject anything that's too long? Yeah. So I guess it's not even so much I gave one counterexample that would invalidate the password checker algorithm that you provided. But there's a ton of other considerations. If you're, say, another process and you're able to listen in or sneak out some other types of information or about power usage or what types of computation it's doing at any given point, you can still do side channels in that regard. And by having a consistent hashing algorithm that's say well implemented ones, because it also comes down to not only the algorithm but how it's actually implemented on the computer. A well implemented appropriate hashing algorithm will more or less make it look exactly the same, no matter what input password you provide to the system. So it should, in theory, allow us to not have to worry as developers of the system of all of these security properties, and we'll just make it work. And I guess on that note, this is probably also a good time to just plug that you shouldn't usually roll your own crypto. If you're ever trying to design your own system for, say, authentication on the web, you might want to avoid writing your own password checkers. Just import someone else that's already written it and done all the algorithms, all the security verification correctly. Small thing, I guess, but it will save you a lot of pain.
I wish more devs would take your words into heart, English so deeply.
Okay. Any other questions? Otherwise, that's all I have for today, guys. All right. Thank you for sticking around. I'm probably half an hour over again.
Yeah.
Oh, I'm only 17 minutes over. This is an improvement.
Yay!